So today let us understand how do we solve a series and parallel circuit, how do we analyze and how do we solve. So I am Professor Mohan BS from Department of EEE SJBIT. So here is a given problem where you have to find R equivalent across AB and AZ for the given circuit. So here you can take any value for R1, R2, R3 and R4. So the method remains the same. So once you, whatever may be the values, apply the same method, substitute, and then you can find. So I'll be solving first for AB. So here point A I have taken as it is and I've stopped at R1, and you can see from between point A and R1, I repeat, from between point A to R1, you can see we have another point or a node. So this node I'll bring it down, and you can analyze that from this node we have another wire which meets R2 and R3. I repeat, from this node which I have marked, it meets two other resistance R2 and R3 respectively. Thus we'll connect one for R2, and from the same junction or node we connect one for R3. Okay, I hope you have understood. So you can see this blue line which is connected to R2, and then we have yellow orange line which is connected to R3. So we have represented or redrawn the circuit. Next, let us analyze at point C. So at point C, you can see we have, I want you to analyze what all connections are there. So at point C, so we have one for R4 and one going to R3 and B, and one going to R2 and one at R1. So these are so many elements which are actually connected at point C. So at point C, one is going for R1, is going for R4, another is going for R2, and another one is going for R3 as well as B. So let's connect all them. Once, let us start with R4. You can see it's connected with blue color wire, and then we have R2 with green color, and then we have the last one which is left out with orange color, it is R3, as well as we have black one which is point B. So now we have rewritten the circuit. So it's not required that every time we rewrite the circuit. If it's not able to analyze by visual inspection, then you can rewrite the circuit by keeping the junctions and nodes in the mind and then analyze it further. So I think now it is evident that all three R1, R2, R3 are parallel across A and B. Then what about R4? So we have to neglect R4. Why? Because we are connecting only across A and B. So if I connect a supply across A and B, the current would flow depending upon the value of R1, R2, R3, and then it will come back to point B. If my terminal A is being positive, the current would go to point A and then come back by point B. There is no flow of current in R4, so it's not electrically connected to the circuit. And now let us solve for AZ. So until here the steps are same. Now where is point Z? Yes, I hope you identified correctly. It is after R4. So you can see point Z when I consider. So the points A and B are not valid now. That means I'll be connecting my supply between A and Z. So when I connect the point between A and Z, the current would go from A and come out from Z. Thus this time it will flow, the current would flow through R4, and thus it is connected electrically to the circuit, and because of this reason alone we have to consider what is R equivalent with respect to R4 also. But how? So until last step, across A and B, R1, R2, R3 are parallel. Are they still the same? Yes, they are still parallel even between A and Z also. And after that we have to add R4. So these three branches are together parallel, we get one value, and then the entire value is in series with R4. So whatever is the value, respectively substitute for R1, R2, R3 and R4, and then you can find your answers. So that is a problem to find R equivalent across A and B as well as A and Z for the circuit shown. So let's take another problem to find out total resistance and then the supply current. So I want you to pause the video and analyze for which elements are in delta and which elements are in star, And where do we apply? Like where do we first apply? Whether we are using delta to star transformation or star to delta transformation. So I want to pause the video and analyze and then come back. So I hope you have identified it rightly, that 30, 12 and 20 are in delta, 12, 20 and 60 are in star. And then we also have 5, 25 and 50. No, we cannot say that. Those elements are not connected, right? So these, I think these two you have identified. But we need not apply any one of these two. Yes, you heard it right. We need not apply either of these transformations, because we can just simply solve this by series and parallel combination. I would say that 12 and 60 are in parallel. I repeat, 12 ohm and 60 ohm are in parallel. Now, I hope you will understand that we can connect the circuit in this way and still it is electrically same. So what is that line? The line, the 12 ohm which is transferring down, it is traveling along the wire. And right now, it is still in parallel. So 60 and 20. So the first step, 12 and 60 are in parallel, and you get the answer as 10 ohm. I hope you are clear. I hope you are aware. We have discussed that in class. Like what is the formula for the parallel equation for parallel? It's 12 into 60 by 12 plus 60, or 12 inverse plus 60 inverse. The whole inverse, you get the answer as 10 ohm. And now from here, how do we solve? So can I say 20 and 30 ohms are in parallel? Or can I say 25 and 10 are in series? Or can I say 20 and 10 are in series? The next step, 20 and 10 are in series, is 30 ohms. And what is the third step? How do we solve further? Now can I use delta to star transformation? No, always analyze whether they are in series or parallel. If none, then you have to use either delta to star or star to delta. But here I would say 30 ohms and 30 ohms are in parallel. You can see each 30 ohms I have common ends. Yes, so 30 I can rewrite in this way. I can take the wire still up and thus here, and you can see both meet the common ends. Thus I can say 30 and 30 are parallel. It is 30, as I have discussed shortcut in the class. 30 by 2 we get 15 ohms, or you can use the normal conventional formula. So what's the fourth step? What is the fourth step here? Can I say 15 and 10 are in series? Yes, it becomes 25. And you can see I've written that easily so that you can analyze that 25 and 25, the next step, are in parallel. 25 and 25 are parallel, it becomes 25 by 2. And if I have 325 ohms in parallel, it becomes 25 by 3. If I have 10 25s in parallel, I repeat, I have 25 ohms 10 times, and 10 times, and 10 times also they are parallel. The shortcut, as we discussed in the class, it is 25 by 10, it is 2.5. In this case, it is 25 by 2, it is 12.5. And now we have single loop, and thus in the loop all the three passive elements are in series. It is 32.5 ohms. And this is R equivalent appearing across your supply. What about total current? So I is equal to V by R. We get current as 3.864 amperes. So thank you for watching the video. Please subscribe for the channel to enrich your knowledge. Thank you.